Hello friends, let me begin by asking you a question. When did you last visit a garden or a countryside? Well, I'm sure that you must have been awestruck by the variety of flowers that you saw either in the garden or in the countryside. You may have also wondered, is there any basis on which they can be grouped? Well, it's not very difficult to group the flowering plants. Today, we will observe the external features of plants and learn how to classify them into monocots and dicots. You have already learned that all flowering plants are called angiosperms. Angiosperms are further divided into monocotyledonous plants and dicotyledonous plants. We hear the word cotyledons, which is common. But what is a cotyledon? Cotyledon is a part of the seed. And what is the function of cotyledon? Cotyledon provides nutrition to the embryo which is present in the seed during the time of germination. Now let us see that the basis of classification of angiosperms, that is into monocotyledonous and dicotyledonous plants, which is the cotyledons, how we can observe it in the plants. I have a few samples of seeds. This is a bean seed. This is a gram seed, and this is the chickpea seed. On the other hand, I have maize as the monocot seed and a wheat grain as the monocot seed. Now these seeds have been soaked beforehand. Why have I soaked them? So that we can see whether they can easily split into two cotyledons. Now I'm going to perform a small activity in which we will try to split the seeds into two cotyledons with the help of a mounting needle. First, I'll take the maize seed and I'll try to press it wherever I can see the groove. But I am unable to split it into two. In the same way, I take the wheat grain and try to press the needle slightly at the groove. Here also I am unable to split it into two cotyledons. And now I will try to split the gram seed into two. And voila, I can split it along its groove into two cotyledons. So we conclude that maize and wheat, they are monocotyledonous plants because they have only one cotyledon, and bean, gram and chickpea, they are dicotyledonous plants because we could split their seeds into two cotyledons. So here, friends, we see that the basis of classification of angiosperms into monocots and dicots lies at the seed stage itself. Those plants which have seeds with two cotyledons are known as dicots, and those plants which have seeds with only one cotyledon are known as monocots. So before we begin comparing the external features of monocots and dicots, let me show you a few specimens of these. This is a periwinkle plant which is a dicot, and this is amaranthus which is a dicot. This is a lily plant which is a monocot, and this is a wild grass, which is again a monocot. So we will begin by comparing the root system of monocots and dicots. When we compare the roots of monocots and dicots, we see that the monocots have fibrous roots and dicots have tap roots. But what is the difference between fibrous roots and tap roots? Fibrous roots appear to originate from a point in the stem, but they are almost of the same size. In the taproot system, there is a central tapering root which has branches originating all along the length. In the taproot system, there is a central root which tapers downwards. It has lateral branches all along its length. So we see that monocots have fibrous roots and dicots have tap roots. After seeing the differences in the root system, we will see the differences in the leaves. Let us begin with the shape of the leaves. Monocots have long and narrow leaves. As we can see here, another specimen of monocot, long and narrow leaves. Dicots have comparatively broader leaves, as you can see here in the periwinkle plant. Another specimen of broad leaf of dicot is that of hibiscus plant. Going from the shapes of leaves, we will go towards how they are attached to the plant. Next, we will see the difference in the attachment of leaves to the stem. Monocots have leaves which are attached by the bases because they do not have a leaf stalk or a petiole, and dicots have a leaf stalk or a petiole which attach the leaf to the stem of the plant. Another difference that we find in the leaves of monocots and dicots is about leaf venation. Leaf venation is the arrangement of veins in the form of a pattern. In monocots, we see that the veins are going parallel to each other, and in dicots we see that the veins are in the form of a network. So in the monocots we have parallel venation, whereas in dicots we have reticulate venation. You must have seen sometimes decomposed and dry leaves lying around, showing the venation very clearly. Here I have a sample of peepal leaf in which you can see a beautiful lacy pattern of veins in the leaf, which is called reticulate venation. Now we will see the differences between the flowers of monocots and dicots. Here I have a specimen of a monocot flower. In monocot flowers we see that the floral parts, sepals and petals are not differentiated clearly. Another feature of a monocot flower is that its floral parts are in numbers that is a multiple of 3. This is a dicot flower. Its floral parts are in numbers that are multiples of 4 or 5. In this particular flower, we can see that there are 5 petals, 1, 2, 3, 4 and 5. Similarly, there will be 5 sepals, 1, 2, 3, 4 and 5. We will count the number of petals in a monocot flower: 1, 2, 3, 4, 5 and 6. In the same way, the stamens which are visible are also 6: 1, 2, 3, 4, 5 and 6. In a dicot flower, we will count the petals: 1, 2, 3, 4 and 5. So, you see that between the monocots and dicots, there are some external features through which you can differentiate between the two groups. These days, we have inclusive classrooms where we have students who could be visually impaired or hearing impaired. I have a few tools through which we can explain the differences between the external features of monocot and dicot plants to them. This tool, which has got raised boundaries, will help the visually impaired students to run their fingers and find out the differences between the shapes of taproot and fibrous roots. As we can see over here, there is a tapering straight root in the taproot with lateral branches and roots originating from the same point, almost of the same size, in the fibrous roots. There is another chart which has got raised boundaries showing the shape of a leaf. There is the midrib and the lateral branches, which will give an idea to the visually impaired student about the venation. Another chart is showing all the parts of a dicot plant: the roots, the stem, the leaves, the fruits and the flower. With the help of these aids, I am sure that even those students who are impaired, either visually or hearing impaired, can understand the differences between monocot and dicot plants. I am sure that next time when you go to a garden, you will surely look around and find out the differences between monocot and dicot plants on the basis of external features that we have just seen. Thank you for watching.